My name is Grasley, and I'm in the Civil Engineering Department, and my research is primarily focused on cement-based materials and improving them as infrastructure materials. Portland cement concrete is the most widely consumed material in the world after water, and it's not even close. The other building materials are orders of magnitude less, and it doesn't matter if you're measuring by mass or volume. Part of that is because of what concrete is comprised of. It's comprised of silicon oxides, aluminum oxides, calcium oxides, and these are the components that make up Earth's crust. A lot of people don't realize the demand for infrastructure materials worldwide. It's so high that we could not build our infrastructure out of materials other than those primary elements that comprise the Earth's crust. And so concrete is going to continue to grow. The demand is going to continue to grow as developing countries around the world develop their primary infrastructure. And so it's imperative that we make a concrete that's going to last a long time to preserve and conserve natural resources and to avoid filling our landfills with degraded materials that have been taken out prematurely. Infrastructure is what I would refer to as an enabling technology. When you have a quality civil infrastructure, it enables you to advance in many other areas of science and engineering and technology. So if you want to develop better research in the areas of, say, cancer treatments or heart disease treatments and so on, you need infrastructure to support that. You need hospitals, you need transportation, and you need quality buildings, quality roadways, quality bridges, all of these things. When concrete starts to degrade, there are huge consequences. And some of these are very obvious, as for instance, the cost to replace civil infrastructure. And then there are also costs that are maybe not so obvious. You know, when it takes you an extra hour to get to work every day because of construction on a roadway, where they're replacing a bridge deck or replacing a pavement. That's lost time, that's lost efficiency, that's a cost. And in fact, it's a pretty significant indirect cost of having to replace concrete infrastructure that maybe wasn't as durable as it should have been. In general, our infrastructure system in the United States is quite mature. And that means that most of what we're spending in terms of infrastructure right now is not to build new expressways, new high-rises, and so on. It's actually to replace, retrofit, and upgrade existing infrastructure, in large part because the materials are starting to degrade. When you make even small improvements in the sustainability, the durability, the resiliency of cement-based materials like concrete, you make huge improvements in the quality of life in your society by improving your infrastructure, making it last a lot longer, reducing the cost, the direct and the indirect costs associated with that infrastructure.